We are doing chapter 5, lesson 2, and we're in the second half of lesson 2. So, yesterday we talked about the basics of exponents, the rules from it was review, and we did some extra, some square root problems as well. So, today we're continuing on, and the big focus of today is I want the roots, the index, the number, the little number to be the same. And in some cases, when I add and subtract, I want what's inside the radicand under the square root to be the same number. And that's when I can add and subtract. Because as it is on number 1, if I have, this problem and there's a rad 16 and a rad 2, those aren't the same. I can't do anything. And a rad 32 and a rad 4, those aren't the same. I can't do anything. So I need to make sure that I'm simplifying inside so that I have the same, we call it the radicand. All right, so here we go. Here's up top. Yes, you can add rad 6, rad 6. Awesome. No, leave as is. I can't do a thing. Things must match up. Like terms. Sorry. Is there a third root of 16? Number 1. So is there a number that goes into 16 that's a third root? Am I going to die right now? Just kidding, I'm not. Maybe. All right. Is there a number that goes into 16 that's a cube root? Yeah. 8 times 2. Cube root of just 2. This is good news. This cube root of 8 comes out as a 2. 2 times the cube root of 2 minus, and this is like a 1 times the cube root of 2. I want you to just think of this as like 2 whatever, 2 square minus 1 square. Doesn't matter that it says 3 root 2. It's just 2 of something minus 1 of something. 2 of the same thing minus 1 of the same term, variable, whatever you want to call it. So I don't want your brain to think that this is any more difficult than like a 2 box minus 1 box. The answer is 1. And then what's the box? Oh, the box is 3, rad 3, 2. So it's like, if the variables are the same, if the roots are the same, all that, then I just add or subtract as normal. Same thing happens with number 2. Change 32. She's in the back with black belt. Yeah. Okay. And then, so I'd split up 32 into 16 times 2, but 4, you guys, rad 4 is a perfect square. So that would be just like 4 times 2. So this actually is not going to have any like terms in common. This is just going to be 4 rad 2 plus 8. 4 rad 2 plus 8. And really the 8 needs to be in front. 8 plus 4 rad 2. Proper formatting, the square roots go at the end and a plain old number goes first. That's just a formatting rule for the order. 20. Break it up. I really want them to have the same number underneath. 20 is 4 times 5. 600. What's the biggest perfect square that goes? 4 goes into 600, but isn't there a larger one? 100. 100 times 6. Rad 25 is just a plain old. So, simplify it. The 4 is a perfect square. 2 rad 5 minus 10 rad 6 minus 5. There's nothing special about this. Okay. So let's go to number 4. What do you think we should do on number 4? You tell me. I need more than that, though. Like what to do? You want to tell me? Take out x squared? So this is a square root, right? So I have, he's saying like use x squared because this is x to the 5th. So it's like 4 x squared, and x. That makes 5 minus x rad. Now split up x cubed into x squared times x. We're going to take out whatever we can because it's a square root. Okay. Square root of 4 is 2. Square root of x squared comes out as just an x. Square root of this x squared comes out as just an x. Rad x. Then minus x. Oh, x squared comes out as an x. This x to the 1st is alone. It stays under. So 2x squared rad x. So I'm simplifying now. Minus x squared rad x. So they both have a rad x. And it's 2x squared minus an x squared. So I have 2x squareds, and I'm taking an x squared away. So how many x squareds do I have left? 2x squareds minus another x squared. 1x squared. X squared. And then they both have the same like attachment, the same variable, the same square root. Rad x. That's your final answer. All right, perimeter of the triangle. The inner triangle. So here is the sides. How, right here, how big is this piece right here, from here to here? 3, because the other side is 4, and then there's 1. Top line, 4. Okay, so now we're doing Pythagorean theorem. I have this triangle. I have this triangle. And I have this triangle. It's finding the hypotenuse on all 3 of those. Okay. Tables 1, 2, and 3. Do this Pythagorean theorem problem, the 3 and the 4. Tables 4, 5, 6. Do this Pythagorean problem with the 1 and the 2. Tables 7, 8, 9. Do this Pythagorean theorem problem with the 2 and the 4. Go ahead.
Which one?
Tables 1, 2, and 3. 3, 4, what? 5. So I'm going to make this 5 right here. Tables 4, 5, 6. 1, 2, and what's the hypotenuse? Rad 5. 1 squared plus 2 squared equals c squared 1 plus 4 equals c squared. C, remember this? Table 7, 8, 9. 2, 4, and what? Don't answer every question. Okay. 2, rad 5. When I want to find the perimeter of the inner triangle, I just add those 3 up, yeah? 5 plus rad 5 plus 2 rad 5. What are the things that I can combine, if any? Rad 5 and 2 rad 5. 3 rad 5. 5 plus 3 rad 5. Good, good, good. 6, 7, 8, and 9. To multiply and combine, like if I want to be able to combine things under the same square root, the root must be the same. However, on number 6, I'm just going to FOIL. So on number 6, go ahead and try and FOIL like you've known from factoring. First, outside, inside, last. Go ahead. Okay. So I started with 4x squared. And then I did outside minus 2x rad 3. So the 2x is going to go in front of the rad 3. I wouldn't put it after because I don't want someone to think that the 2x goes inside the root. So I put it in front. That was first outside. Inside, same thing. Negative 2x rad 3. And last, negative rad 3 times negative rad 3. What is it? Positive rad 9, which is then positive 3. Plus 3. Anything that I can put together? These right here in the middle, yeah. 4x squared minus 4x rad 3 plus 3. Okay. These have the same root, so it's the fourth root of 16. Is anything the fourth root of 16? 2. And then take a break from helping. I need to hear from more people. I don't want to hear from the same people over and over. That's right, though. Number 8 is kind of weird. They don't have the same root. One of them's the cubed root and one of them's the fourth root. I need to make these into rational exponents, fraction exponents. So here's what it looks like on this first one. 6 to the 1/3 times 6 to the 1/4. So I change them into rational exponents. And then I continue to have that 12 out there. Now raise both to the 12th power. Go ahead and do that on your own. And then you're going to have to simplify the exponents. Reduce the fraction. The exponent is going to become a fraction. All right, I'm going to start doing it on the paper. 6 to the 12 over 3 times 6 to the 12 over 4. So I can reduce 12 over 3 to 4, and I can reduce 12 over 4 to 3. Then what? 6 to the power of what? 7. Good. Nine is totally easy. Distribute, but I can't. Well, I can do a little something. Go ahead and distribute. Okay. 5 rad 6 plus rad what? Good job. Break it up, that rad 18. 5 root 6 plus, okay, this is 9 times 2, right? Square root of 9 times 2. 3 rad 2. Nothing can be simplified. I can't do a thing with that. They don't have the same number underneath. It's just like, no. If they were multiplying each other, I could, but not adding or subtracting. Our last topic, the mixed review, I don't have time to do because it's a short day, but rationalizing the denominator. Okay. No square roots in denominators. I think we did this in geometry because I taught geometry and I know we did, hopefully. So you can't have a square root in the denominator. So what I'm going to do is multiply by the conjugate. The conjugate means the opposite sign in the middle. Because the numbers are going to stay the same. So like number 10. In order for me to get rid of that square root, the only way for it to actually cancel out is if I multiply by 2 minus rad 5, and whatever I do to the bottom, I do to the top. So I'm going to multiply the numerator and multiply the denominator. And you'll see that the square root cancels out in the bottom. The numerator, 2 minus rad 5. Okay. I am foiling these bottom denominators here. First, outside, inside, last. Go slow and stay organized. 2 times 2, 4. Outside, 2 times negative rad 5, minus 2 rad 5. Inside, 2 times rad 5, plus positive 2 rad 5. Last, rad 5 times negative rad 5. Ooh. Positive radical 5 times negative radical 5. Negative, take a break. Negative what? Negative rad 25, which becomes negative 5. A lot happens. Like these two cancel out. So then all I'm left with is 4 minus 5 at the bottom. So 4 minus 5 is negative 1. The top, nothing changed. 2 minus rad 5. This really doesn't look that great. Like having a negative 1 at the denominator is kind of weird and no one does that. So you could move it to like the front. I could go like negative sign 2 minus rad 5. Something like that would be fine. I guess you could also distribute the negative, but I'm not going to have you do that. Okay. Real quick on number 12, there's nothing you can do. It's fine as it is. So number 12 is nothing. But number 11 is kind of hefty. Multiply by 2 plus rad 3, top and bottom. Sophia P., can you come up, please? Are you right? Who was the next person? I sent them away. Danya, that's right. Sorry. All right, you're working on number 11. All right, let me start number 11. The numerator, foiling. 10. 5 times 2, 10. Plus 5 rad 3. Minus 2 radical 2. Minus radical 6. Denominator, 4. Now things are going to cancel out in the denominator. That's good. I don't want a square root in the denominator. Outside, plus 2 rad 3. Inside, minus 2 root 3. Last, minus root 9, which is minus 3. The numerator is awful. Nothing goes together. Nothing is a like term. My numerator is going to stay super long as 10 plus 5 root 3 minus 2 root 2 minus root 6. All over 4, take away 3, 1. I don't need to write a 1. So 12 can't be touched. These square roots, or sorry, these short days sure do seem rushed, huh? Okay, I'm going to stop the video.